Hey guys, Mr. Gucci here with your 14.2 worksheet molarity and dilution help video. Okay, so today I'm going to walk through the, let's say, even problems. Okay, I'm going to do the even problems from the first section. So this video is going to be 2, 4, 6, and 8. I'll make another video with 10 and 12 after this, so it doesn't get too long. Okay, so here we go, guys. Of course, with all of these worksheets, your first job is to input your student ID so that it randomly generates your worksheet. I will tell you my actual ID is 0011. That's my employee ID. All right. I'm cool. I get to be number 11. All right. And my name, of course, is David Gucci. All right, guys, let's look at these problems right here. Okay. So all of these equations here, all these problems deal with a single equation, the molarity equation. The molarity, or concentration of a solution, equals how many moles are in the solution, N, divided by the volume of the solution. So let's get to it. Let's start with number 2. Okay, here we go. Give the molarity of a solution comprised of 1.114 moles of sodium chloride dissolved in 5.286 liters of solution. Oops. Solution. All right, so here we go, guys. So the equation is the molarity, or concentration, equals the number of moles divided by the volume. Okay, well, there are 1.114 moles in this substance, in this solution, and the solution is comprised of 5.286 liters. So here we go. Molarity equals 1.114 moles divided by 5.286 liters. Okay, so I'm just going to enter this into, like, I don't know, Google or something. Let's see. Google 1.114 divided by 5.286, and I get as an answer 0.2107. All right, so that's the molarity. All right, the molarity equals 0.2107 M. That M is molar. Okay, so this is the molarity of the solution, 0.2107 molars, right? So we would say this was a 0.2107 molar solution. So we might call this, it might be molarity, or we might call this a molar solution. Either one works. Okay, so 0.2107. Let me plug that in, see if it's right. 0.2107. 0.2107 molar solution. Very good. Now, if you think you got it right, but it keeps showing up as wrong, just make sure you put in enough digits. Like if you put in 0.2 here, thinking that was good, you rounded too much. You got to give me more digits. Okay, let's try this next one. Number 4. Here we go. All right, number 4. Give the molarity of a solution comprised of 0.3125 grams of hydrogen sulfide, H2S, all right, dissolved in 7.84 liters of solute. Oh, I mess this up every single time? Fine. All right, now listen. The formula for molarity is molarity equals number of moles divided by volume. You'll notice here that you didn't get number of moles, you got grams. So your first step is actually going to be to convert those grams into moles, okay? And for that, we're going to need a little bit of the old dimensional analysis, guys. Here we go. Here we go. All right, so we're going from 0.3125 grams of H2S, and we're trying to convert it into moles of H2S. So we want to get out of grams and into moles. All right, you might guys remember how to do this. 1 mole of H2S is how many grams? Well, I'm going to look up the molar mass of H2S. It is 34.1 grams for every 1 mole. 34.1. So this stuff is 34.1 grams per every 1 mole. The grand conclusion here is to convert grams into moles, guys, and you're going to need to do this on the final. To convert grams into moles, you have to take the grams and divide it by the molar mass. Let me find the calculator app on my phone. Do I not have it? What the heck is it? Forget. Back to Google. Here we go. So Google help 0.3125 grams divided by 34.1 moles, and I get the number of moles is equal to 0.00916. Don't just stop at 9, guys. Don't do 0.009. That's too much rounding, okay? So here we go. All right, so the molarity equals the number of moles. All right, this is the number of moles. So 0.00916 moles divided by 7.84 liters. And that gives me 0.00916 divided by 7.842, or 7.84, liters. I get molarity is 0.001168, 0.00117 molar solution. Okay, let's see if that's right. All right, so 0.00117. Hey, I did it. All right, so there we go. That is the concentration of that solution right there. Okay, cool. That was probably the trickiest one. Okay, but let's take a look now at number 10. All right, or what is this? Number 8? What is this, number 10 or number 8? Let's see. Here we go. So number 6. Okay. How many moles are in 6.448 liters of a 6.195 molar solution? Okay, there we go. So I'm going to copy this. Now, you guys can show your work in the work column. Me personally, I like to do it by hand and just attach a picture. All right, maybe I'm old, but nothing for me is as good as just taking out a pencil or a digital stylus and just drawing it out by hand. All right, so the molarity equals the number of moles divided by the volume. Now, in this case, folks, one of the things they gave us was the molarity. All right. And what we are looking for is the number of moles. We don't know the number of moles. We know the molarity. We know the volume. We are looking for the number of moles. This is algebra, guys. Plugging in what we know. 910. The molarity equals 6.195 molar. You don't know the number of moles, but the volume is 6.448 liters. So we're solving for number of moles, okay? We know the volume, we know the number of moles, or we know the molarity, okay? So we're solving for this guy right here, number of moles. Now we got to get it by itself. It's being divided by 6.448. So we're going to multiply both sides by 6.448. Cancel it over here. 6.448. So the number of moles is equal to 6.448 times 6.195. So we got 6.448 times 6.195. And we get 30-something. 39.94. Okay, so 39.9. Let's plug that in, see if that works. 39.9 moles. Okay, all right, that worked out. Next up, last one, we're going to do number 8. By the way, let me write this down here. 39.9 moles. All right, Last one in this video. Here we go. In order to get 12.475 moles of reactant from a 10.552 molar solution, how many liters will you need? So the molarity equals number of moles divided by the volume. The molarity is 10.552. The number of moles is 12.475. And we are trying to find what is the volume in liters. All right, let me just clean this up a little bit. This should be volume. All right, this down here should be volume. So we're looking for the volume. So guys, this kind of problem clearly causes a lot of issues trying to solve for the value on the bottom of a fraction. But I'm going to do a little trick here, guys. Remember, when you're solving for a denominator, you cross multiply. All right, multiply the top of this fraction by the bottom of this fraction, top of this fraction by the bottom of this fraction. But Mr. Gucci, there's no fraction here. Listen, any number is a fraction over 1. Okay, so 12.475 times 1 is just 12.475. And that is equal to 10.552 times V. So V times 10.552. Trying to solve for the volume here. And so we're going to divide both sides by 10.552. We want to get V by itself. It's being multiplied by 10.552. So to undo it, we divide by 10.552. All right, so the volume is 12.475 divided by 10.552. 12.475 divided by 10.552. And the answer is, this volume, we need 1.18 liters. 1.18 liters is the volume that we need here. Okay, 1.18 liters. Let me go plug that in. See how I did. 1.18. A worksheet complete. All right, at least for this video, the sake of this video, I did 2, 4, 6, and 8 for you guys. That's a pretty good sample of the kind of problems you will encounter. All right, good luck. Stop by office hours if you have any questions.